All right, so let's talk a little bit about atomic radius and how we can get an idea of the comparative size of different atoms, of different elements based on periodic trends. Now, a radius for pretty much any spherical type of object, which is the way we tend to model atoms, even though we know in reality they're not going to be totally spherical, is the distance from the nucleus pretty much to the outer edges of the cloud. There's probably a more rigorous way of describing this, but that's good enough. And as you'll see in textbooks, that the periodic trend for atomic radius, which we could just simply call atomic size, follows the periodic table this way. As you go from left to right across a period, across an energy level or row, the atom is going to contract. And as we go down a column, we assume that as we add energy level, the atom will get bigger. So let's first address the trend of left to right across a period, and then we'll address the trend of up to down in a column or an elemental group. So here's an example. Let's say we're on the second energy level. So you want to be looking at your periodic table, of course, when we're discussing this, or it doesn't make a whole lot of sense. So we have lithium way off to the left along with the alkali metals, and then fluorine, which is a halogen, and we're reaching near that noble gas column. So what happens is they both have two principal energy levels, even though we're just going to look at this as a Bohr model. We're not going to look at it in a quantum sense. But we've got the first energy level, that would be, N1, and then we have two. You see that here are both. So why is it that even though they have the same number of energy levels, that fluorine is actually smaller in its overall atomic size? Well, that's because lithium has 3 protons and 4 neutrons in the nucleus, whereas fluorine has 9 protons and 10 neutrons in the nucleus. And we need to remember that the main factor is that opposites attract, and so electrons being negative will feel a stronger positive force pulling on it in the nucleus if the nucleus has more protons. We have a difference of 6 protons between lithium and fluorine, so you can understand why this increasing amount of positive charge in the nucleus is tugging on the electrons in this cloud, thus contracting those shells, as we call them, and giving an overall smaller size to fluorine. Also, the fact that these outer electrons are on the second energy level and are already pretty close to the nucleus anyway explains why fluorine is the most electronegative element. Its electronegativity is really high, since it's going to take a lot of energy to pull an electron off of the electron cloud of this extremely negatively oriented body. So that explains that trend. Let's take a look at the trend of increasing size as we go down a group. So we look at a comparison of two metals, of alkali metals, in the first column, leftmost column of our periodic table here, lithium and sodium. And you can see why, as you go down a column in an elemental group, that you have an increase in size, because even though both of these elements have one valence electron on their outer shell, that's why they behave similarly chemically, this one has 2 energy levels. It's over 2N in the notation that we see in textbooks, whereas sodium has 3 energy levels. It's on the 3rd row, so we're adding energy levels. So basically what happens is, as we add more protons on an row, going from lithium to beryllium and then boron to carbon to nitrogen to oxygen to fluorine and neon, we see an increasing amount of positive charge as we add more protons, which tugs on that second energy level and the first one as well, and contracts the size of the element. But as we go down a group, we are adding more and more energy levels. So how to tell if you're sort of in that middle zone, and where like you may have an element, you're comparing two elements, and one's on the second energy level and the other's on the third energy level, but the one on the third energy level is much further to the right. Let's say it's chlorine compared to, say, lithium or beryllium on the second energy level. So some of the factors start canceling each other out, and in the end, when you get down to that, you pull out the atomic radius chart and actually look and see how many picometers in atomic size we've got. But a lot of times on quiz questions with this skill, they tend to make it fairly obvious. And so you wind up seeing what you would say is an overall diagonal trend. As you go from upper right to lower left, you can see more or less an increasing size. Once again, there's exceptions to this, but generally with a lot of test questions, they'll say compare 4 elements for atomic size, and one will be over here, and one will be over here, and one's here, and one's maybe here, and you can see just sort of a general trend, at least on quizzes like Mr. Money.